of chemical kinetics. In this module, we are going to understand units of rate constant. What you really do need to understand though is that the unit of rate constant depends on order of the reaction. Both order and rate constant come from the rate law expression, so they have to be interrelated. Let's take a zero order reaction and understand what will be the unit of rate constant for it. Let's write the rate law expression first. It will be rate is equal to K into concentration raised to 0, because it's a zero order reaction, my dear friends. So here A raised to 0, the concentration of A raised to 0 is 1. Anything raised to 0 is 1. So I can say that rate essentially is equal to rate constant. Or if I equate the units on the left hand side with right hand side, I can say that mole per liter per second, that's the unit of rate of reaction if you remember, is equal to K. Which means that the unit of K for a zero order reaction is mole per liter per second. That is the unit of rate constant for a zero order reaction. Let's consider a first order reaction. For a first order reaction, the rate law expression can be written as rate is equal to K into concentration of A raised to 1. If you equate the units on left and the right side, you can say that mole per liter per second is equal to K into mole per liter, because the unit of concentration, my dear students, is mole per liter. When you balance out, when you cancel out the common terms on both the sides of equal to, you will be left with K is equal to second inverse. Mole per liter and mole per liter will get cancelled on both sides. So we can say that the unit of rate constant for a first order reaction is second inverse. Isn't it easy, my dear students? Now let's go for the next one, that is a second order reaction. Do the same thing. Rate is equal to K into concentration of A raised to 2, because it's a second order reaction. Again, equate the left and the right side units. You will get mole per liter per second is equal to K into mole per liter whole square. Once again, if you rearrange this equation, you will get K is equal to 1 upon mole per liter into second, which can be rearranged as liter per mole per second. So I can say that the unit of rate constant for a second order reaction is liter per mole per second. Come on, let's try this for a third order reaction. Let's do the same thing. Let's write the rate law expression. Rate is equal to K into concentration of A raised to 3. It's a third order reaction. Let's write the units on both left and the right side of the equal to. We will get mole per liter per second is equal to K into mole per liter whole raised to 3. Again, cancel out the common terms. Rearrange the equation. You will get K is equal to 1 upon mole per liter whole square into second. And this can be rearranged as liter square per mole square per second. So I can say the unit of rate constant for a third order reaction is liter square per mole square per second. In fact, what I can really do is I can write a general unit for any nth order reaction. So all you have to do is write the rate law expression for nth order, that is rate is equal to K into concentration of A raised to N. Now here, once again, write the units on both sides of the equal to. You will get mole per liter per second is equal to K into mole per liter raised to N. When you rearrange this equation, you will get K is equal to mole per liter whole raised to 1 minus N per second. And that, my friends, is the general unit of rate constant for nth order, mole per liter whole raised to 1 minus n per second. In fact, if I were to write the units of rate constant for n number of orders, the table would look like this. Suppose if I have 0 order, first, second and third order reactions. For a solution, this will be the unit of rate constant for different orders. We have already derived these units. But what is interesting is, if the reactants are gaseous, then this mole per liter gets replaced by atmospheres. So this will now be the unit. In fact, if you take the nth order, for nth order we have already derived the unit for solutions, that is mole per liter whole raised to 1 minus n second inverse. For a gaseous reaction, mole per liter again gets replaced by atmosphere. So that's your unit right there, atmosphere raised to 1 minus n per second. This is because if you have more moles in a given volume, the pressure of the gas is more. So mole per liter can kind of be equated with atmosphere. That's how you find out the unit for rate constant. See you in the next module, my dear students. Till then, take care.